Alright, so today we are going to review the midpoint formula. So we're going to talk about midpoints and segment congruence. So the first thing that we need to look at is, what is the midpoint formula? So let's review what that is. So first of all, there's two different formulas for midpoint. There's a formula for the midpoint on a number line and formula for midpoint in the coordinate plane. So here's the first one. On a number line, the midpoint is, the suspense is killing you, I know. You're going to take the numbers, let's just say that they're A and B. You'll add the numbers together and divide by 2. For instance, here would be your number line. Let's say that you have the number 3 here, and then you have this number here, 8. And you want to find the number that's directly in between 3 and 8. 3 represents A, 8 represents B. So wouldn't you take 3 plus 8 and divide that by 2? What's 3 plus 8? 11 over 2. So you can either have your answer as 11 halves, or because it's on the number line, it might make more sense to use the mixed number. What's the mixed number? How many times is 2 going to 11? Or 5 and a half. So if we worked ourselves outwards in, there's 1, there's 1, there's 1, there's 1, wouldn't this point right here be the midpoint in between 3 and 8? And is that point 5 and a half? Here's 3, here's 4, here's 5. Isn't that 5 and a half? So here's the midpoint, 5 and a half. So if it's a number line, you're just adding the numbers and dividing by 2. What's that like, similar to?
Mean.
The mean, or the average. All you're doing is averaging the numbers together. All right, but what if we're in the coordinate plane? Because we have an x and a y value. In a coordinate plane, the coordinates of the midpoint are and it's very similar to the number line. We're going to take, remember your ordered pairs would be x sub 1, y sub 1, x sub 2, y sub 2. Well, we're going to take those x values and we're going to add them together and divide by 2. That's going to give us the x value of the midpoint. Then you're going to take the y values of those coordinates, add them together, and divide by 2. So your two coordinates are x sub 1, y sub 1, and x sub 2, y sub 2, meaning 0.1 and 0.2. So let's go ahead and do an example of number 2. Example 1, you are going to need a straight edge. Find the midpoint. Of RS, segment RS. Now, they might give you the actual ordered pairs, or you might be given a coordinate plane with the points plotted, and you have to figure out the coordinates yourself. So So let's assume that they did the latter, which requires more work on your part. Everybody should be taking notes. R is at -3, -4. So here's R. And S is at, oops. R is at -3, -4. And S is at 5. 5, 7. So here's S, way up here. So we are going to try to find the midpoint of this segment. Now, this is a diagonal line. You cannot just count squares and find halfway between. I suppose technically you could measure the line and take half of that measurement and put a dot there and try to figure out the coordinate pair, but what if it's a fraction or a decimal number? You're just going to be guessing. The midpoint formula is quick, it's easy, and it's going to give you an exact answer. So it doesn't matter which is 0.1 and which is 0.2, or what's x sub 1 and what's x sub 2. You decide, it won't make a difference. Let's say that this is x sub 1, y sub 1, and this is x sub 2, y sub 2. We're going to apply that formula. So to find the midpoint, we're going to take the two x values, -3 and +5. We're going to add them together and divide by 2. You're going to do the same for the y's. You're going to take the y's, -4, and add 7 to it and divide that by 2. You may or may not have a number that's divisible by 2. That's okay. What's -3 plus 5? 2. What's 2 divided by 2? 1. So the x value of the midpoint is 1. What's -4 plus 7? Positive or -3? Positive 3 over 2. So that's 3 halves, right? You could write your midpoint coordinates like this, or you can look at it as 1 what? What's 3 halves as a mixed number? 1.5. Let's plot that and see if it actually falls on this line segment and see if it looks like it's in the middle. So you're going to go to the right one, up 1.5. So here's the right one, up 1.5. Does that look like it's in the center of that line segment? Yep. So it's not that hard, is it? But if I ask you for the midpoint, don't use the distance formula, right? You have to know which formula to use in which instance. All right, last example. Can I flip this page? Yes. Okay, that's fine. You don't want my page? Okay, I'll send it down. You send that down. It's coming back, Esteban. Oh, I thought you said you still wanted it. Oh, okay. Good enough. All right, so example 2. This one, there's no pictures associated with it. You have to write it all out yourself. So here we go. So example 2. My orange pen is dying already. It says U is the midpoint of segment XY. If XY and when I don't put anything above XY, what is it that I'm referring to? The distance or the measure from X to Y is equal to 16x minus 6, and uy, again, the distance from u to y, is 4x plus 9. Find the value of x and the measure of line segment xy. Now here's where segment congruence comes into play. If you go back and look at what we did on example 1, what would you say about the distance from R to the midpoint and from the midpoint to S? What would you say about the distance of these two segments? What does the midpoint do to the overall big segment? It splits it in half. So what would you say about this segment versus this segment? They're what? They're equal to each other. So anytime that you're told that something is a midpoint, you know that the two segments that that midpoint creates, because a midpoint will create two segments on a big one, that these two segments are equal. That is a conclusion that you must automatically draw. They're not going to spell it out to you. They're not going to tell you that, oh, remember, since that's a midpoint, those two segments are equal. You have to draw that conclusion yourself. So, can't I draw that conclusion in this problem here? If U is the midpoint of segment XY, can't I draw a segment XY? So we are going to use the 4-step plan because is this or is it not a word problem? Yes, Mrs. Murray, it is. So we're going to draw a picture, we're going to label our picture, and we're going to set up an equation to solve. You will find that those of you who showed the 4-step plan on your quiz earned extra credit. Those of you who did not earn extra credit. That is if you did the problem correctly. All right, so here's our 4 steps. We're going to draw a picture. So I'm going to just draw a segment and label it XY. So here's my line segment. Here's X and here's Y. And remember, this is our let statement. It says U is the midpoint. So I'm going to put U directly in the middle. And I'm going to even put midpoint here to remind myself. And I might even put here that, remember, XU should equal UY. Because if that's the midpoint, there's a conclusion that I've drawn. I need to know that this segment equals that segment. And then they give me some more information. They tell me that XY, isn't that the whole thing, is equal to 16x minus 6. From here to here, that whole distance. And then they tell me something about UY. They said UY was 4x plus 9. Find the value of x. Now, one of our postulates, previous postulates, is coming into play here. Which one would that be? I heard it. The segment. What? Nope, the segment what postulate? What postulate says that this plus this equals the whole thing? The segment addition postulate. These two pieces add to give you that, but because this is the midpoint, what do you know about this piece also? It's also equal to 4x plus 9, isn't it? So they didn't tell you anything about xu, but you know, because that's the midpoint, that it's also equal to 4x plus 9, and this right here was key. If you can't come up with that, you can't set up the equation to solve. If you can't make that conclusion that these two pieces are equal, you're not going to put that amount there. Does that make sense? Okay, so now we can write our equation to solve, and you can write it 2 different ways. What's one way? Give me one way to write that equation to solve. Okay, 4x plus 9, and I'm just going to put these in parentheses to separate them. You could take the 2 separate pieces and set them equal to the 16x minus 6. Here's the 2 smaller pieces added to the bigger piece. How could you shorten this work? How else could you have written this same equation? Yeah, 2 parentheses 4x plus 9 equals 16x minus 6. Either one of those are perfectly acceptable. Now all you have to do over here is do the math. So you solve it algebraically. The rest is a piece of cake. You're going to solve it, and then over here you answer the question. Just because we solve for x does not mean we answer the question. So you do the math. Go ahead. You have 1 minute. Make sure that you collect your x terms first before you move any constant numbers. When you get an answer, share it with a person sitting directly across from you or around you. Everybody has to share with somebody. You got a value for x, share that. Now answer the question, because just because you have a value for x, does that answer the question? Nope. So look at the question, answer it. Come up with a therefore statement. Therefore, come up with a full complete sentence. All right, stop. What value did we get for x? 2? 3. 3 is correct. So here's what your algebra work should have looked like. You should be moving, I used the distributive property, and I got 8x plus 18 is equal to 16x minus 6, then you have to be moving the x terms first. If you've got variables on both sides, you should not be moving the 18 first. Because 8x is smaller than 16, I chose to move the 8x by subtracting it. And then I moved the constant 6 by adding it to both sides, and then dividing by 8. That's proper algebra. If your work doesn't look like that, you're doing it wrong. Now, what's the question? We found the value of x, so there's one piece, and then we have to find the measure of xy. Well, go back to your picture, right there. xy is the whole distance from here to here. What expression represents xy? 16u minus 6. Could you have used also 18x plus 18, or 8x plus 18? They're equal, right? You could have. But what might have happened here that you might not want to use this? What might you have done here? You might have made a mistake. Of course, if you made a mistake here, more than likely you would not have gotten x is equal to 3. And then couldn't you plug in x is equal to 3 into this up here to see if you do get equal segments? So you can check your answer. So let's go ahead and plug in xy is equal to 16x minus 6. And then we are replacing x with 3. And so we get 16 times 3. What is that?
48.
48 minus 6 equals 42 units, right? So what would be a good therefore statement? One person, raise your hand. Nobody's brave. It's not that hard. That's the easy thing. Look at the question and answer it in a complete sentence. Therefore, there are two parts to it, right? You cannot put x equals in there. I mean, like with an equal sign. Therefore, the value of x is means equals, right? 3. And the measure of segment xy, and you can have those kinds of notations in your sentence, is, not an equal sign, 42 units. Question? If you use words, yes, you could. Okay? Any other questions on this? This last problem encompasses everything that we did on Friday, and talking about that congruent segments, or congruence of segments, and everything that we did with midpoint. But this one happens to deal with midpoint on a line. It really wasn't the number line. We really didn't have to add the segments together and divide by 2 like we did in example 1. It was more talking about that if you have a midpoint, those segments are congruent. Okay? All right.